Hello everyone. Today we are going to solve question number 14 from GATE 2022. This is a complex analysis question. We have to find the value of this integral. Right. So as we can see in the denominator there is something z power 101 and in the numerator there is z power 100. So derivative of z power 101 is 101 into z power 100. So we can sort of adjust this 101 here. We will get the derivative of function in the denominator in the numerator. So suppose if we make some adjustment like 101 z power 100 upon z power 101 plus 1, just divide the whole thing by 101. So this is z power 100 divided by z power 101 plus 1. So this is, if we assume f of z equal to z power 101 plus 1, then in the numerator we have f dash of z. So it is, we have to find integration of f dash of z upon f of z dz over this given c, where c is the circle of radius 2 centered at the origin. Right, and then we will divide this by 101. So we have one theorem for calculating this integral. So this theorem is Cauchy's argument principle. Let's just see the statement. If f of z is a meromorphic function. Now what is a meromorphic function? It is a function which is analytic except only at some poles. So if it have singularities, it can be only poles. It cannot be removable singularity or essential singularity. Right. So it only has poles. So if f of any analytic function is meromorphic as well. So if f of z is a meromorphic function, inside and on some closed contour C, and f has no zeros or poles on C, then 1 over 2 pi I integral over C f dash of z upon f of z dz, this is equal to z minus p, where z is number of zeros of f inside C and p is number of poles of f inside C. Okay, so here we have f of z equal to z power 101 plus 1. So clearly this function is analytic everywhere on the complex plane. So it will be analytic in this circle of radius 2 centered at origin as well. Right. So we got p is equal to 0, this p, because it doesn't have any poles. Now let us find out number of zeros inside this C. To find zeros of f of z, let f of z is equal to 0. This implies z power 101 plus 1. This is equal to 0. So this implies z power 101 is equal to minus 1. So let's just take this 101th root on both sides. We will get z is equal to minus 1 power 101. Now if we take modulus on both sides, we'll get mod z equal to 1, right? So this means that if z is a 0 of f, then modulus of z is 1, right? So clearly f of z has 101 zeros. in complex plane, right? So we have to find number of zeros of f inside C. What is C? C is the circle with radius 2 centered at 0. Okay, this is 2 minus 2, 2 minus 2. So where does this mod z is equal to 1 lies? This is exactly here, where we have 1 here, 1 minus 1 minus 1. So as we can see, every zero of f lies inside this outer circle C, right? So we have all 101 zeros lie inside C. So this implies z is equal to 101. So all the zeros of f lies inside C. Therefore, now let's just use this principle. We will get integral over C 1 over 2 pi I f dash of z upon f of z. This is equal to dz equal to z minus p. What is z? Z is 101, p is 0. So this is equal to 101, right? Let's solve this hand side. Now we have 1 over 2 pi I. Or see, what is f? F is z power 101 plus 1. So f dash of z will be 101 z power 100 dz is equal to 101. So 101 101 will get cancelled. So we get integral over c z power 100 divided by z power 101 plus 1 dz is equal to, take 2 pi I on this side, 2 pi I. So this is the answer, right? Let's check which option is it. So it is option D. Right? So option D is correct option. I hope you all understood the solution. Thank you.